I hope you guys are fine, just like me, and are doing great. First of all, let me introduce myself. My name is Daniela Foylin Narasiang. I'm a pharmacy student, second semester at Samratulangi University, Manado. And I made this video to fulfill the final exam assignment for the physics chemistry course. So stay tuned and hopefully this video can provide knowledge to all of us.
Alright, now I'm gonna explain you about dipole moment, which is a submaterial of interactions of systems with electric and magnetic fields from chapter 12 about basic terms of chemical physics. So, what is a dipole moment? A dipole moment is a pair of opposite electric charges of magnitude q at a distance L constitutes an electric dipole. A dipole moment arises in any system in which there is a separation of charge. They can, therefore, arise in ionic bonds as well as in covalent bonds. Dipole moments occur due to the difference in electronegativity between two chemically bonded atoms. A bond dipole moment is a measure of the polarity of a chemical bond between two atoms in a molecule. It involves the concept of electric dipole moment, which is a measure of the separations of negative and positive charge in system. The bond dipole moment is a vector quantity since it has both magnitude and direction. And this is an illustration that describing the dipole moment that arises in an hydrochloric acid. As you can see, it can be noted that the symbols delta plus and delta minus represent the two electric charges that arise in a molecule, which are equal in magnitude but are of opposite signs. They are separated by a set distance, which is commonly denoted by d. And these are the important points of dipole moments. First, the dipole moment of a single bond in a polyatomic molecule is known as the bond dipole moment, and it is different from the dipole moment of the molecule as a whole. Second, it is a vector quantity. It has magnitude as well as definite directions. Third, being a vector quantity, it can also be zero as the two oppositely acting bond dipoles can cancel each other. Fourth, by convention, it is denoted by a small arrow with its tail on the negative center and its head on the positive center. Fifth, in chemistry, the dipole moment is represented by a slight variation of the arrow symbol. It is denoted by a cross on the positive center and arrowhead on the negative center. This arrow symbolizes the shift of electron density in the molecule. And the last one, the sixth, in the case of a polyatomic molecule, the dipole moment of the molecule is the vector sum of the all present bond dipoles in the molecule. And this is a dipole moment formula. A dipole moment is the product of the magnitude of the charge and the distance between the centers of the positive and negative charge. It is denoted by the Greek letter mu, so mathematically, dipole moment or mu equals charge or Q times distance of separation or L. It is measured in dB units denoted by D. So, 1D equals 3.33564 times 10 to the power of 30 cm, where C is coulomb and M denoted as matter. And the bond dipole moment that arises in a chemical bond between two atoms of different electronegativities can be expressed as follows, where mu is the bond dipole moment, Delta is the magnitude of the partial charge, delta plus and delta minus, and d is the distance between delta plus and delta minus. The bond dipole moment, or mu, is also a vector quantity whose direction is parallel to the bond axis. In chemistry, the arrows that are drawn in order to represent dipole moment begin at the positive charge and end at the negative charge. When two atoms of varying electronegativities interact, the electrons tend to move from their initial position to come closer to the more electronegative atom. This movement of electrons can be represented via the bond dipole moment. This is an example. This is the example of dipole moment of BeF2 or beryllium fluoride molecule. In a beryllium fluoride molecule, the bond angle between the two beryllium fluorine bonds in 180 degrees. Fluorine, being the more electronegative atom, shifts the electron density towards itself. The individual bond dipole moments in a beryllium fluoride molecule are illustrated below. So, you can see the two individual bond dipole moments cancel each other out in beryllium fluoride molecule because they are equal in magnitude but are opposite in direction. Therefore, the net dipole moment of a beryllium fluoride molecule is 0. And this is a special reminders about dipole moment. First, in terms of the electric charge distribution, a molecule represents a much more complicated system containing positive charge or atomic nuclei and negative charge or electrons. In more complex molecules, the dipole moment depends on the type of atoms and their mutual orientation. The overall dipole moment is the vector sum of the dipole moments of individual bonds. And so that's it from me. Thank you for watching and listening. Stay healthy and keep cheer up. Kisses and hug for all of you. Once again, thank you very much. Bye.